Now let us move on to the next segment of the first unit, that is electric field. The unit name is electric charges and field. In that we have finished electric charges. Now we are moving on to the second chapter, electric field. Quite an easy idea, must understand properly. See, I consider a charge Q placed somewhere here. There is a charge Q placed at some point, say A, and it is fixed to its position. What do I mean by fixing? Try to understand. See, this charge may experience force due to some other charges or many other mechanical forces. In spite of all those forces acting on it, the charge would not execute motion in any other direction. That is most important. In no direction it is executing motion, therefore we say that it is fixed onto its position. Resultant of all the forces has been made zero on this charge. Okay, this cannot move. Keep this in mind. And now, around this charge, you can recognize a region. Around this charge, you can recognize a region in which if you bring another charge, it experiences a force. Try to understand the idea. Say I keep now another charge, maybe Q dash, somewhere here at the point B. Q dash experiences a force, either attractive or repulsive based on the nature, due to the charge placed at the point A. Okay. So if you keep another charge somewhere here, even this is going to experience the force. If you keep a third charge here, it will also experience a force. Like that, around this charge, there exists a region in which you bring any other charge at any point, it will experience a force. That region around a charge in which another charge experiences an electrostatic force is itself called electric field. What is it called? Electric field. You must understand. It is some sort of influence the charge is producing in a region that is surrounded by this. Okay? You must understand this idea. Suppose, ನಾನು ಇಲ್ಲಿ ಇಟ್ಟಿದ್ದೀನಿ charge. It is experiencing force. If I keep the charge here, then it is experiencing force means there is a field there. If you keep the charge here, and if it is experiencing any force, then field is also present there. Like that, field will be present at every point wherever another charge experiences force. ಆಗ ನಿಮಗೆ ಒಂದು ಡೌಟ್ ಬರುತ್ತೆ, ಸರ್ ಹಾಗಾದ್ರೆ ಈ ಚಾರ್ಜ್ ಸುತ್ತ ಎಷ್ಟು ಏರಿಯಾ ಇದೆ ಆ ಥರದ್ದು ಅಂತ ಕೇಳಿದ್ರೆ, you can find a very large volume of space around it. ಯಾಕೆ ಗೊತ್ತಾ? ನಮಗೆ ಗೊತ್ತಿರೋ ಹಾಗೆ force between two charges. In my present situation, force is equal to 1 by 4 pi epsilon naught QQ dash divided by distance square. Isn't it? QQ dash divided by distance square. Now, this force will become zero in the region where there is no field. Okay? If you say there is no field due to this charge, if the field is not there somewhere around it, then at that point force must be zero. When force becomes zero, it is 1 by 4 pi epsilon naught QQ dash divided by d square. Or I can say, see, 1 by 4 pi epsilon naught is anyway constant, cannot be zero. Q and Q dash are two non-zero charges. Therefore, only possibility of getting this value equal to zero is that distance is infinity. Okay? When this distance becomes infinity, then force drops to zero. At any point if the force is zero, then field is not existing. Therefore, around a charge, if you want to find the zero force, you must go to which point? You must go to a point whose distance is infinite. Okay? When distance becomes infinite, force drops to zero. Therefore, you must follow the point that electric field around every charge extends up to infinity. Most important. Electric field due to every charge extends up to infinity, goes up to infinity. Therefore, every charge produces an infinitely long range electric field. One more question can be raised like this. What is the range of the electric field? Due to any charge, whatever you consider, every electric field extends up to infinite position. You cannot restrict the electric field to a finite dimension, because every charge is capable of producing the field up to infinity. Maybe at some point of time, its influence may reduce, but it is there. Effect suppose if I go to a point very close to infinite, but it is a finite distance, very large distance. When the distance is very large, maybe force is very small, but still it is existing. That is important. Okay. Therefore, every charge produces a field which extends up to infinity. Now the next question is how to test the field. How do we measure the strength of the field? Let us understand that idea. How to measure the strength of the field. Very easy to follow. Q1 or maybe Q. Now, due to this charge, I want to measure the field somewhere here. How do we actually recognize the field? I told you. Wherever I want to see the field, I keep a charge there. If it is experiencing any force, I say that there is some field. Okay. So field is always recognized by force. And therefore, field strength is measured in terms of magnitude of the force. You must understand. Field and the measure model. Field idya anta check madbekadre navu ಏನು ನೋಡ್ತೀವಿ, force ಇದೆಯಾ ಇನ್ನೊಂದು ಚಾರ್ಜ್ ಮೇಲೆ ಅಂತ ಚೆಕ್ ಮಾಡ್ತೀವಿ. ಆ force magnitude ಎಷ್ಟಿದೆ ಅಂತ ನೋಡ್ಬಿಟ್ರೆ that gives you the strength of the field. But you may get a doubt now. Sir, while calculating the force, I will considering the product of two charges. ಹಾಗಾಗಿ ಇಲ್ಲೊಂದು ಚಾರ್ಜ್ ಇದೆ, ಇಲ್ಲಿ ಒಬ್ಬ 1 ಕೂಲಂಬ್ ಚಾರ್ಜ್ ತಂದಿರ್ತಾನೆ, ಇನ್ನೊಬ್ಬ 2 ಕೂಲಂಬ್ ಇರ್ತಾನೆ, ಇನ್ನೊಬ್ಬ 3 ಕೂಲಂಬ್ ಇರ್ತಾನೆ. Each one will find different values of the force at that point. Do you mean to say the field is different at that point? No. ಇಲ್ಲ, ಹಾಗಲ್ಲ. ಅದಕ್ಕೆ ನಾವೀಗ ಇನ್ನೇನು ಮಾಡೋಣ ಅಂದರೆ, ಈ ಥರ ಒಬ್ಬೊಬ್ರು ಒಂದೊಂದು ಚಾರ್ಜ್ ತರೋದಕ್ಕೆ ಪ್ರಾವಿಷನ್ನೇ ಕೊಡೋದು ಬೇಡ. Now we will restrict. Wherever you want to measure the field, there you must keep a +1 coulomb charge. We will make this a rule. Wherever you want to measure the field, you keep a +1 coulomb charge there. Therefore, there is no question of bringing different charges. Standard test charge. What is it called? Standard test charge. And this is called source charge. Source charge and standard test charge. You must understand this. Okay. So Q is the source charge and the Q dash, in place of Q dash I have placed +1 coulomb. That is the standard test charge. So if you measure force on a standard test charge, then you get the strength of the electric field marked as electric intensity. Therefore, I write like this: electric field strength or electric intensity is nothing but force experienced by force on a +1 coulomb charge kept at that point. See, if you change the point, force changes. If you change the point, force changes. Therefore, electric intensity is always defined for a point. It is always for a point. You must remember. It is always for a point. Now we will produce a definition. Try to understand. If I want to find the electric intensity here, always it is therefore defined for a particular point. Electric intensity at a point in an electric field is always the force experienced by a unit positive charge kept at that point. Must remember, electric intensity is nothing but electric intensity at a point in an electric field is nothing but the force experienced by a unit positive charge kept at that point. Electric intensity at a point in an electric field is the amount of force experienced by a unit positive charge kept at that point. Keep this fact in mind. Okay. Suppose now you may get it out. Sir, +1 coulomb charge ತಗೊಂಬನ್ನಿ ಅಂತ ಹೇಳಿದ್ರಾ. I don't have +1 coulomb charge. ನನ್ನ ಹತ್ರ ಇರೋದೇ 20 coulomb. ಅವಾಗ ಏನು ಮಾಡಲಿ ಅಂದ್ರೆ you bring 20 coulomb. You bring 20 coulomb. Measure the force. Say ಸುಮ್ಮನೆ ಎಕ್ಸಾಂಪಲ್ಗೆ say on a 20 coulomb charge. On a 20 coulomb charge. See, say the force is equal to 500 Newton. On a 20 coulomb charge, 500 Newton force is there. But to measure electric intensity, I should always do the calculation for 1 coulomb charge. So, 20 coulomb ಗೆ 500 Newton ಇದ್ರೆ ನಾವೇನ್ ಮಾಡಬೇಕು ಈಗ electric intensity ಬೇಕಾದ್ರೆ 20 coulomb ಗೆ 500 ಆದ್ರೆ what is it for 1 coulomb I must check. How do I do that? I divide 500 by 20. 20 coulomb ಗೆ 500 Newton divide ಮಾಡ್ತಾರೆ. ಅವಾಗ each coulomb gets a force of 25 Newton. So 25 Newton for every coulomb. 25 Newton per coulomb is the electric intensity. So now we can write a formula for this. How did we calculate electric intensity here? Electric intensity calculation is done by taking the ratio of total force to total charge. Therefore, F by Q gives you electric intensity. Electric intensity is F by Q. And it's a vector quantity because we are using force for the measurement of field. Force is a vector. Therefore, vector force by charge is vector intensity. Electric intensity is therefore E is equal to F by Q. E is equal to F by Q. You must understand this fact. Therefore, unit ಗೊತ್ತಾಗುತ್ತೆ ನೋಡಿ ಇಲ್ಲ. Force ಅಂದ್ರೆ Newton. Charge ಅಂದ್ರೆ coulomb. Newton per coulomb is the SI unit of electric intensity. How do we write dimensions for this? Very simple. Dimensions of electric intensity is equal to dimensions of force divided by dimensions of charge. Forces mLt minus 2 and charges at. Therefore, this is mLt minus 3 a minus 1. Try to understand. mL t ಇಲ್ಲಿಂದ minus 1 ಆಯ್ತು, ಇಲ್ಲಿ minus 2 already ಇದೆ. T minus 3 a minus 1 is the dimensional formula for electric intensity. Okay. So we have followed few important points. An electric field is the force experienced by a unit positive charge kept at that point. Definition first. ಎರಡನೇದು electric intensity extends up to infinity. ಮೂರನೇದು electric intensity extends up to infinity can be pronounced in the other way. Electric field is an infinitely long range field. ಮೂರನೇದು electric field is measured in terms of force. Since force is a vector quantity, electric intensity is also a vector quantity. Electric intensity is given by F by Q. E is equal to F by Q. Unit of electric intensity is Newton per coulomb. Electric intensity dimensional formula is mLt minus 3 a minus 1. I think you have followed up to it clearly. Don't think there is any doubt. Okay. Charge placed at the point A, fixed onto its position. Now, I want to measure the electric intensity somewhere here at the point say B. I have told you to measure the electric intensity, you must first keep a +1 coulomb charge there. When you keep a +1 coulomb charge, it starts experiencing a force. That force, say, I assume that this is also a positive charge. Since the charges considered are like charges, the electrostatic force experienced will be repulsive and it will be along this direction. Whatever the direction force follows, same is the direction followed by the electric intensity. So electric intensity exists in this direction. If I assume that the distance of separation is some d, the distance of separation between A and B is d, then we can arrive at an expression for electric intensity something like this. We know that electric intensity is equal to force by charge, isn't it? It is the ratio of force experienced to the charge magnitude kept at that point. So E is equal to, and let me replace one term here. I will replace Q by QT. QT stands for Q test. Test charge is here 1 coulomb. So 1 coulomb agrinda denominator alli 1 bandubidutte. So electric intensity is equal to force. How do we calculate force? 1 by 4 pi epsilon naught product of charges. Product of charge means what? Q into 1, which is simply Q, divided by distance square. So vectorially I write electric intensity as 1 by 4 pi epsilon naught Q by d square into d cap. So whenever I want the vector, when I know the magnitude, if I multiply it by a unit vector in that direction, what is the direction of d cap here? Direction of d cap is like this. It is along E. So if I multiply the magnitude by a unit vector in that direction, I get the vector form. So vector form of the electric intensity is this. There may be a question for 2 marks, something like this. Derive an expression for electric intensity due to a point charge. This may be a question. Very simple answer for this. You first consider a charge, select a point, keep a +1 coulomb charge there, measure the force on that. That force itself is electric intensity. I think you have understood this clearly. So here afterwards, electric intensity is given by 1 by 4 pi epsilon naught Q by d square. What is this Q here? This Q is always the source charge. What is this? Source charge. So where is the place of test charge? Test charge is not finding any place because it is 1 coulomb. Product of that becomes Q only. Adrinda test charge all bardirodu. ಇಲ್ಲಿ ಬರ್ದಿರೋದು ಯಾವುದು? Source charge. So 1 by 4 pi epsilon naught source charge divided by distance square is electric intensity. Okay, I think you have understood this. See, in the derivation we have followed a result. Now let us apply that to different points. Let this be a source charge, and I am considering a point somewhere here P, whose distance is some x. Here I want to measure the electric intensity. How do I measure the electric intensity? Electric intensity E is equal to 1 by 4 pi epsilon naught source charge divided by distance square. Here I have marked the distance as x, therefore I am writing x square in the denominator. Okay, its direction will be along this line, repulsion along the line joining 2 charges. What is the charge that we have kept here? +1 coulomb. Now, if I select the same point somewhere here, at the same distance x, then also it will experience the repulsion, but that is along this direction. Again, electric intensity in magnitude. This is a point P, this is some M. What is intensity at P? This expression. What is intensity at M? Again it is 1 by 4 pi epsilon naught charge divided by x square. See, EP and EM are remaining same in terms of magnitude, but are they same in terms of direction? No. Therefore, at 2 different points where the electric intensities are same due to a point charge, they cannot be same in terms of directions. They may be equal, identical in terms of magnitude, but never in terms of direction. Now if you want to maintain the direction, the force will be in this direction. Aga E point alli electric intensity direction same aitu. Direction. But now we have a different distance. Aga electric intensity ಏನಾಗುತ್ತೆ at the point n 1 by 4 pi epsilon naught q divided by y square it becomes. So what do you understand by this? At different points in the electric field, you can never have, at two different points in the electric field, you can never have the electric intensity the same magnitude in same direction. So if the magnitudes are same, directions will be different. If the directions are to be made same, magnitudes will vary. Therefore, either in terms of magnitude or direction or in terms of both, the electric intensity will differ. Therefore, we will come to a conclusion. At no 2 points in the electric field strength can be same. Okay? So on the charge sutta, you cannot find two different points where the electric intensity is same in terms of both magnitude and direction, which is not possible. Must remember this fact. Electric intensity cannot be same at two different points due to a monopole. A single charge producing the field is called monopole. Now we will understand the direction of the electric field due to different types of charges. Let me rub this. Standard test charge. Then it will be repulsion of this kind. So you keep the +1 coulomb charge at whichever the point you want. Everywhere the electric field is directed away from the source charge. Isn't it? Everywhere the electric field is directed away from the source charge. Suppose if I consider a negative charge producing the field at the point A. Here at the point B I am keeping a unit positive charge, standard test charge. Minus q will not repel it, rather minus q attracts it. Aga everywhere the electric intensity is directed towards the source charge. Due to a negative charge, field direction is towards it. Due to a positive charge, field direction is always away from it. Okay? I think you have followed all these ideas. Okay? Now, electric dipole. You must follow this carefully. See, in the earlier section, whatever we have discussed regarding the field, it was all about the field produced by a single charge. Field produced by a single charge is monopole field. What is it called? Monopole field. Now I am considering dipole and dipole field. Very easy to follow. Dipole. Di stands for two. Pole stands for the polarities. Here dipole stands for a system of two charges, two unlike charges of equal magnitudes separated by some small distance. Dipole is an arrangement where you have two charges of the same magnitude but of opposite nature separated by some small distance, say d. Or you can mark. Now usually mundin derivation we mark this distance as 2a. A from the center on one side, from the center on the other side, the other a. Total distance is 2a. Here afterwards we will fix this as a convention. What is that? In case of dipole, always the distance measurements have to be done from the center. Must understand. Okay? Q and minus q are therefore the two charges which have been separated by some small distance to a. This arrangement is called dipole. If some question is raised, something like, what do you mean by dipole? Dipole is a system of two equal charges of unlike nature separated by some small distance. Such an arrangement is called an electric dipole. Okay. Now, this dipole is characterized in terms of a physical quantity called dipole moment. See, ಈಗ ನಾವು ಯಾವುದಾದ್ರು ಒಂದು ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟಿನ ಕ್ಯಾರೆಕ್ಟರೈಸ್ ಮಾಡಬೇಕಾದ್ರೆ ಅದನ್ನ ಈಗ ಈ ತರದ್ದು 10-15 ಡೈಪೋಲ್ ಬಂದ್ರೆ I must be able to distinguish one dipole from the other dipole. So ಆ ಡೈಪೋಲ್ಗಳನ್ನ ಡಿಸ್ಟಿಂಗ್ವಿಶ್ ಮಾಡೋಕ್ಕೆ we use a character called dipole moment. It is a defined character. ಈಗ ಹೇಗೆ ಅದನ್ನು ಡಿಫೈನ್ ಮಾಡೋದು ಅಂತ ನೋಡೋಣ. Dipole moment is symbolized by the letter P. P is always equal to the product of distance of separation between the two charges. Product of distance of separation between the two charges with the magnitude of either of the charge. No sign, only magnitude here. You can consider the magnitude of any of them because magnitudes are same for both. Only they are different in terms of nature. Okay. Hagagi product of magnitude of the either of the charge with the distance of separation in between is called dipole moment. Must remember, dipole moment is a vector quantity. That's why I multiplied by pk. But what to positive charge? Must keep this in mind. It's a defined quantity. Its direction has been defined from negative charge to positive charge. Dipole moment is directed always from negative charge to positive charge. I write it here. Direction of the dipole moment is from negative to positive charge. Okay, it is from negative to positive charge. Okay, dipole moment is a vector quantity. Let us now check for the unit of this. Unit of dipole moment. 2a is length to be measured in meters. Q is charge to be measured in coulomb. So meter coulomb is the unit of dipole moment. Meter coulomb. What is its dimensional formula? Dimensional formula for dipole moment is 2a as a length term. Charge for that we have written at. M mass term illa. Therefore m0 LAT, or simply you can write this as LAT. That is the dimensional formula for dipole moment. Okay. Dipole ಅಂದ್ರೆ ಏನಂತ ಗೊತ್ತಾಗಿದೆ. Dipole ಅನ್ನು ಕ್ಯಾರೆಕ್ಟರೈಸ್ ಮಾಡೋ ಕ್ವಾಂಟಿಟಿ dipole moment. Dipole moment ಗೆ ಫಾರ್ಮುಲಾ ಗೊತ್ತಾಯಿತು. Dipole moment as a vector ಅನ್ನೋದು ಗೊತ್ತಾಗಿದೆ. ಡೈರೆಕ್ಷನ್ ಆಫ್ ದಿ dipole moment ಗೊತ್ತಾಗಿದೆ. ಅದರ ಯೂನಿಟ್ ಮತ್ತೆ ಅದರದ್ದು dimensional formula. All these things we have followed. Okay? Right? We will proceed now. As one charge, and this is minus q, the other charge responsible for producing a dipole. These two have been separated by a distance 2a. A on one side and A on the other side. Now I want to measure the field due to a dipole. Try to understand. I am measuring field due to a dipole. In the first case, I consider field due to a dipole at a point on the axial line. Try to understand. I am considering now field due to a dipole at a point on the axial line. Try to understand what do you mean by axial line. The line which passes through the two charges of the dipole. Line which passes through the two charges of the dipole is called an axial line. You can even consider it on that side. For my comfortability, I am considering it here. Somewhere here, I want to find out the field. Let me mark that point as some m. At this point, I want to measure the field due to a dipole. So at that point, wherever I want to measure the field, I should keep a +1 coulomb charge. Isn't it? It is our usual practice. Whenever we want to measure the electric intensity, we keep a +1 coulomb charge there. But now, this +1 coulomb is under the influence of two charges. Isn't it? Q and minus Q are influencing simultaneously the charge placed at M. Now let us say, what is the interaction combination? Let me mark this point as A and this as B. See, the charge at A is a positive charge. Charge at A is positive, plus 1 coulomb is also positive. Positive repels positive charge. Therefore, force or field due to the charge at A will be repulsive along this direction. Okay? Whereas the charge at B, which is due to negative charge, that will exert attractive force over this. Attraction anna hege represent martini. This is intensity due to charge at B. But see here, while writing, I have written a short vector for this, but this is quite a longer vector compared to this. So, if you negative charge is more closer, therefore it will produce a greater influence on this. Therefore, EB is greater than EA. It's the most important point. In my diagram, EB is greater than EA. Okay? What are EA and EB? Now let us find out that. From the center, I have told you the convention, all the distances that we are measuring in case of dipole, that should all be done from the center of the dipole. Therefore, from the center of the dipole to the point, let the distance of separation be equal to some r. Let it be equal to some r. I will write now the expression for electric intensity due to the charge at A. Try to understand this. E due to A is 1 by 4 pi epsilon naught charge at A divided by distance from A is how much? A plus R. Distance from this A is small a plus R. Therefore, this is R plus A whole square. Correct? R plus A whole square. Now, EB, adhan hege bariyodu? EB is 1 by 4 pi epsilon naught. Charges minus Q. But now minus sign na tagobeda illi. In munde we'll fix this as a rule. You know, in the calculation of intensity and force, sign of the charge is just meant for judging the direction. During the calculation of its magnitude, I don't consider it. Therefore, I simply write here Q. Must understand. I didn't write minus Q. Now the distance is, total is R. This A has to be removed. Therefore, this remaining distance is only R minus A from B to M. Therefore, this is R minus A whole square. Did you understand this? I think you have followed. EA bariyo again madde 1 by 4 pi epsilon naught charge by total distance square. EB bariyoga 1 by 4 pi epsilon naught charge divided by, I want only this distance BM. What is BM equal to? BM equal to R minus A. For our reference, in barkondirtini bekadre AM is R plus A, whereas BM is equal to R minus A. That is what I have used. Okay. Now, EA and EB are acting in opposite directions. Therefore, what is net? Or net electric intensity E will be along the direction of the greater vector EB, and it will be the difference of EB and EA. Therefore, net electric intensity is EB minus EA, and it is along the direction of greater vector, that is EB. So, E is equal to EB minus EA along the greater vector EB. What is EB? EB is equal to 1 by 4 pi epsilon naught Q by R minus A whole square minus 1 by 4 pi epsilon naught Q by R plus A whole square. Okay. Now, taking out the common factors, epsilon naught into 1 by R minus A whole square minus 1 by R plus A whole square. I think you have understood. Q and 1 by 4 pi epsilon naught are common factors. Ache tagonbiಟ್ಟಿದ್ದೀವಿ. ಅದರಿಂದ Q by 4 pi epsilon naught in multiplied by, let me take the LCM here, r plus a whole square minus r minus a whole square whole divided by r minus a into r plus a. ಎರಡಕ್ಕೂ ಸ್ಕ್ವೇರ್ ಇರೋದ್ರಿಂದ I write the common square. ಎರಡಕ್ಕೂ ಸ್ಕ್ವೇರ್ ಇದೆ. Okay. So this is in the next step. Q by 4 pi epsilon naught. It is looking like a plus b whole square minus a minus b whole square. What is that? A plus b square. Formula ಗೊತ್ತಿದೆ ನಿಮಗೆ. Square minus a minus b whole square is always equal to 4ab. Similarly, r plus a whole square minus r minus a whole square must be equal to 4ra. 4ra divided by r minus a into r plus a is r square minus a square, r square minus a square whole square. Okay, this can be reorganized a bit. Try to understand. I write this as 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught. 4ra along with this q, I write like this, 2 times 2r times 2aq. Is it okay to write like this? See here, 2 2s are 4. raq, raq, everything is same. Divided by r square minus a square whole square. How do I write it for that? E is equal to, let me rub that part, 4 pi epsilon naught 2r. See, 2aq product is nothing but dipole moment. Therefore, I write it as P divided by r square minus a square whole square. Okay. This is the expression for electric intensity at a point on the axial line. Now, if I consider this point very far from the dipole, try to understand, for a far away point from the dipole, r will be very large compared to a. So, r is much greater than a. In that case, a becomes negligibly small. See, when a itself is smaller, square of that number will be much more smaller. See, 0.1 anta one number ide. 0.1 square madidre 0.01. Square of the smaller number will be much more smaller. So I can just drop that. So dropping that, we write E as equal to 1 by 4 pi epsilon naught 2rp divided by r square. This can be neglected. R square square becomes r power 4. Or simply E is equal to 1 by 4 pi epsilon naught 2p divided by r cube. That is the expression for intensity. Now see the direction. Direction of the electric intensity is from negative charge to positive charge. ಇಲ್ಲಿ ನೋಡಿ ಇಲ್ಲಿ ಕಾಣುತ್ತೆ ಈ ಡೈರೆಕ್ಷನ್ ಇದೆ ಅಲ್ವಾ ಇದು resultant intensity E, which is EB minus EA, is along the direction like this, that is from negative charge to positive charge. Therefore, electric intensity is along the direction of dipole moment. Remember, dipole moment is also directed from negative to positive charge. Intensity is following the direction of the dipole moment. Therefore, intensity vectorially is 1 by 4 pi epsilon naught 2p by r cube into p cap. Electric intensity follows the direction of dipole moment. Therefore, I multiply it by p cap, which is a unit vector in that direction. Okay. So this is the expression for electric intensity. Remember, this is a most probable question for 5 marks in the examination. ಕೇಳಿದ್ದಾರೆ question ಏನಿರುತ್ತೆ, derive an expression for electric field due to a dipole at a point on the axial line. For a point on the axial line, field is given by that. 1 mark question ಕೇಳ್ತಾರೆ, how does the electric intensity vary with the distance? So in that case, what do you write? Electric intensity due to a dipole at point on the axial line varies with the distance inversely with the cube of that distance. It varies inversely with the cube of that distance. Important 1 mark question. I think you have followed the derivation clearly. 1-2 minutes. Pakka nodkoli correct age. We'll move on to the next topic. The equatorial line we will consider. Equatorial line. First, let us understand what is equatorial line. Let me write it here. I am considering a dipole somewhat like this. This is charge q. This is another charge minus q. They have been separated by a distance 2a. Now, equatorial line is the perpendicular bisector for the line joining two charges of the dipole. Just remember, it is the perpendicular bisector for the line joining two charges. So at some point here, I am interested to find out the field. There I keep a standard test charge 1 coulomb. Now let us judge the interaction. Nodo, e distance iga a. This distance is another a. Now this is the equatorial line length. Length of the point should be measured from the center of the dipole. Let it be equal to some r. Now see, charge at this point a. This is b. Charge at this point a will repel this charge because this is positive and this is also positive. So these two are positive charges. Therefore, charge here, test charge here. Source charge anyway will not move. Test charge, they can execute motion. They can experience force. Hagagi, force is felt in this direction. This is the electric intensity at the point M due to the charge at A. Sir, force ಅಂದ್ಬಿಟ್ಟು E ಬರಿತಾ ಇದ್ದೀರಲ್ಲ ಅಂದ್ರೆ 1 coulomb ಮೇಲಿರೋ ಫೋರ್ಸ್ ನೇ ತಾನೇ ಇಂಟೆನ್ಸಿಟಿ ಅಂತ ಕರೆದಿರೋದು. Force on unit positive charge is itself intensity, therefore I am writing that as EA. ಅದೇ ಈ ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ ಇದೆ ನೋಡು. ನೆಗೆಟಿವ್ ಚಾರ್ಜ್ instead of repelling, negative charge will attract it. I mark this as EB. Must understand. Okay? EA and EB are the two electric intensities. In Pythagoras theorem prakara, if this distance is A and this is R, this hypotenuse length must be equal to R square plus A square within square root. And this distance is exactly same as this. Okay? Now let me measure the magnitude of EA. Magnitude of intensity due to the charge at A is 1 by 4 pi epsilon naught 1 by 4 pi epsilon naught charge at the point A divided by distance square. Distance square becomes just R square plus A square because square root is square root ಮಾಡಿದಾಗ just becomes R square plus A square. On the other side, EB is equal to 1 by 4 pi epsilon naught charge divided by R square minus R square plus A square, because this distance is also equal to R square plus A square. If you observe, EA in magnitude is same as EB. EA, EB are equal magnitude, but EA and EB are vectorially not same. ಎರಡು ಬೇರೆ ಬೇರೆ ಡೈರೆಕ್ಷನ್ ಬೇರೆ ಇದೆಯಲ್ಲ, ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಒಂದೇ ಆದರೂ ಡೈರೆಕ್ಷನ್ ಬೇರೆ ಬೇರೆ. Now I want to find out the resultant of these two intensities. To find the resultant, let me resolve EA and EB to the components. I'll resolve them into their respective components. How do we do that? Let's understand. ಈಗ ಈ ರೆಫರೆನ್ಸ್ ಆಂಗಲ್ ನ ಥೀಟಾ ಅಂತ ಅನ್ಕೊಳ್ಳಿ. Since it is an isosceles triangle, this must also be theta. If this is theta, the corresponding angle, this should be theta. and alternate angle, this should also be theta. Now, angle pakkadallirodu, side adjacent to the angle always takes the cosine component. This becomes EA cos theta and this becomes EA sin theta. Isn't it? Similarly, EB angle pakkadallirodakke EB cos theta. And for the other side, it is EB sin theta. First year alli resolve model helpotide. We are using that. Now, since EA is equal to sin theta is exactly equal to EB sin theta. Right? Understand? EA EB equal agirodrinda EA sin theta must be equal to EB sin theta. But EA sin theta and EB sin theta are in opposite directions. See, they are equal but acting in opposite directions. Therefore, they cancel with each other. They are equal but opposite in direction. Therefore, those two terms will cancel with each other. You are left only with the other two terms. Therefore, net electric intensity with you will be, since these two are in the same direction, I must add them. EA cos theta plus EB cos theta, or in other words, E is equal to EA plus EB into cos theta. EA plus EB into cos theta, or E is equal to, what is EA? We have written the expression. Anyway, EA and EB, they are same in magnitude. Therefore, what do? I can write this as 2EA or 2EB. They are equal into cos theta, or E is equal to 2 times EA. We have the value here. I use that. 1 by 4 pi epsilon naught Q divided by R square plus A square into cos theta is. From the diagram I can recognize that. Cos theta, cos theta is adjacent side by hypotenuse. Therefore, you can write this as what? A by root of R square plus A square. 2 divided by, see, it is looking like R square plus A square into R square plus A square 2A cube product. Therefore, it is 1 by 4 pi epsilon naught 2A cube product is dipole moment. Illi power 1 ide, illi power half ide. Therefore, it is R square plus A square to the power of 1 plus half. 1 and a half is 3 by 2. Okay, 1 plus half, 1 and a half is 3 by 2. This is the expression for electric intensity. Here also, if I select the point very far from the dipole, that is, if R is much greater than A, in that case, E will be 1 by 4 pi epsilon naught P by A is negligible. R squared to the power of 3 by 2 is just R cube. Now, if you look at direction, dipole moment is directed from negative to positive. Dipole moment direction is like this, whereas resultant field is like that, opposite to the dipole moment. Therefore, while writing vectorially, electric intensity is 1 by 4 pi epsilon naught P by R cube shall be multiplied by minus P cap. You are understanding why is it so? Why? I am multiplying it by minus P cap because resultant intensity is in a direction opposite to the dipole moment. Therefore, resultant intensity is given by this expression. Here also you find that electric intensity varies inversely with cube of the distance. Okay, varies inversely with cube of the distance. This is another important derivation. Field due to a dipole at a point on the equatorial line. Okay, I think you have followed up to here clearly. These two are two important derivations which we have finished today. In the next class, we will continue with few more such important topics. So, attentive ಆಗಿ ಇದನ್ನು ನೋಡಬೇಕು, ಮನೆಯಲ್ಲಿ ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಬೇಕು. Minimum 2-3 times write in practice ಮಾಡಿದ್ರೆ ಮಾತ್ರ you can have a good retention of this content. Okay, thank you. We'll continue in the next class, right?